Hello! In this video I'm going to be doing an example of a stoichiometric calculation involving solutions, also known as molarity, which is moles of solute over liters of solution. Got this little worksheet right here entitled Stoichiometry Solutions. I'm going to do number 2 because that one's a little more challenging, a little more involved. It says how many mils of 0.5 molar NaOH is needed to neutralize 50 milliliters of 2.00 molar H2SO4. Alright, so they give me the molarity of NaOH, they give me the volume and molarity of H2SO4. So which substance, H2SO4 or the NaOH, could I use the molarity equation to find moles? It's going to be the one where I'm given two numbers. Because remember, the molarity equation is, let me just write it right here, moles of solute over liters of solution. Alright, so we have our volume, which is liters of solution, we've got our molarity, we can find moles. Taking a step back, why don't we look at our stoichiometric buddy sheet. It's 1 through 5 are the steps. First step is write and balance the equation. Alright, write and balance equation. So I know I have NaOH and I have H2SO4. Those are my two reactants. They're neutralizing each other, which is just a acid-base term to explain that they are fully reacting with each other to produce salt and water. It's a neutralization reaction. Alright, so I know water is produced. I always circle the H2 of my acid, or all of the H's of my acid, and all of the OH's of my base. And that's going to form my water. You might ask, whoa, this is 3 H's, 1 O, that's H3O. But water is not written that way. It's written as H2O. We're going to fix that H3O, H2O dilemma by adding coefficients when we balance it. So I just put H2O plus, I've got SO4 and Na. They're going to come together to form my salt. And it's always the positive one that comes first. Na being 1 plus, and SO4 being 2 minus. We crisscross it to balance it out. That 2 goes there, that 1 goes there. Na2SO4. Alright, now we're going to add the coefficients. We've got 2 sodiums, 1. So I'm going to put a 2. That gives me 2 oxygens. I only have 1 here, so I'm going to put 2. I ignore those oxygens because I'm counting the SO4s as one entity. 1 SO4, 1 SO4, I'm good with that. I have 2 H's, plus 2 H's is 4. 2 times 2 is 4 H's, and it looks like it's balanced. Alright, so we said that we're going to start with H2SO4 because we have all the information required to find moles of that substance. So I'm going to write down my 2 molar, and this equals X moles divided by my liters. They give me milliliters. Alright, so I gotta convert that. And the conversion factor is for every 1 liter, there's 1,000 milliliters. You can also do the King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. Converting milli to 1, 2, 3. You're basically moving that decimal 1, 2, 3 spots to the left. And you're going to get 0.05 liters. Alright, now in order to solve this, you got to do algebra. You multiply both sides by your denominator. 0.05 liters. Those guys cancel out. Molarity stands for moles over liters. So if we're taking our liters and multiplying it by moles over liters, our liters are canceling out, and we're being left with moles. Liters times mole over liter. Or you can just think, well, X is my mole, so my unit is going to be moles. Now, in order to solve this, you need to have a calculator with you. Just one moment. Alright. Good thing I didn't need to ask Mr. Huebner for a calculator, because I brought my own. Where were we? We were taking our 0.05 times 2. So 0.05 times 2 equals 0.1 moles of my H2SO4, because that's the substance that we had the information for. Now it's looking like we can do some stoichiometry. If I have 0.1 moles of H2SO4, I need to find out how many moles of NaOH are neutralized, or reacted in this case. So I'm going to do mole-mole ratio, because essentially what I did was I wrote and balanced the equation. I wrote down the given by doing this molarity equation. To find moles, I'm now doing a mole-mole ratio. Moles of NaOH over moles of H2SO4. And I've got 1 mole of H2SO4 on the bottom and 2 moles of NaOH. 0.1 times 2, looks like that's going to give me 0.2 moles of H2SO4. But we're not done yet, because it's asked for how many milliliters of NaOH do we have if it's a 0.5 molar solution. So now I'm going to plug this moles of H2SO4 back into this molarity equation. It's going to be moles of solute over our liters of solution, and that equals 0.500 molar. Molarity equals moles over liters. I'm going to multiply both sides by my x. Let's move it over here. This gives me 0.500x, and that equals 0.2 moles. Divide by 0.500. 0.2 divided by 0.5. Looks like that's 0.4. 0.4 liters, but the question is saying how many milliliters. So now I'm going to multiply this by 1,000 mils per 1 liter. And it looks like that's going to give me 400 milliliters of NaOH solution. And that is my final answer. And that's how I use stoichiometry to solve a problem that involves solutions.